All right, well, here we are for video number 2 from section 8 calculating confidence intervals for one proportion. The truth is, from the first video, you know all the details. You know about the point estimate, you know about the margin of error, which is made up of the critical value, Z star, and the standard error, which is the standard deviation of the sampling distribution for the proportions. So now this is about putting them together. So this whole video pretty much is one example. We will talk a little bit about what Darren calls the four-step process, what Mr. G calls, he calls it the 3 C's. I don't know. We'll talk about that. And I'm going to tell you, he talks about how to calculate a confidence interval manually, but the fact is I'm going to show you how to do it on your calculator, and that'll be it. So here's the example. And again, I know you can read, but I want to make sure you're clear on everything. National AIDS Behavioral Study Surveys found that 170 is the number of people out of a sample of 2,673 that had multiple partners within the last year. Right? 170 divided by 2,673 is 0.0636. Okay? So, 0.0636 is what we got from our sample. But are you willing to say, for the country, oh, yeah, so we think it's 6.4%. I'm not so sure about that. Your boss, Gary at the Sentinel, or somebody says, we want a 99% confidence interval for the true proportion of people, adults with multiple partners. What the heck? Sorry about the example. But the first thing that we need to do, always, Darren calls it state, plan, do, conclude. State, we'd like to find the true proportion, right? So we're going to create a confidence interval. The plan is where we check our conditions. Checking the conditions is always going to have to be part of it. So when it says use the four-step process, state, here's what we want to do. Plan, check the conditions. And those conditions, randomness, normality, and independence. Randomness, normality, and independence. And they can be done in any order. As far as randomness, well, it says up here as an SRS. So we say, we have an SRS. It was truly random. We have met the condition of randomness there, right? So that's solid. Now, Mr. G has his students write out, we have an SRS of this many out of this that represents that. In Darren's book, if you look in our book, Darren says, as long, you can state, it was stated in the problem that it was an SRS, so we have our randomness, so that's okay. The second thing that Mr. G is going to check here is independence. I usually do normality next. He does independence next. Whatever. It doesn't make any difference. Independence is the 10% condition. So, is the whole population, big N, is that bigger than 10 times the sample? In other words, are there more than 26,730 adults? Yeah, I think so. So we're going to assume that that's true. The independence condition, the 10% condition says, hey, we can calculate our standard error. The formula for standard error, square root of p hat times 1 minus p hat all over n. We usually write this as little n has to be less than or equal to 10% of big N. If you take 10% of the population, does that still work? Either way, the population is 10 times the sample, or the sample is less than 10% of the population. And the last thing, for normality, we have to check two things with proportions. N times p hat has to be bigger than or equal to 10, and n times 1 minus p hat. These two conditions are the same. These two things both have to be true. Both of these two products have to be bigger than or equal to 10. So, watch. We'll go ahead and make this calculation. Little n is 2,673. Is 2,673 times that p hat? That's 170. 1 minus that p hat? 2503. Are those bigger than or equal to 10? Absolutely. We can proceed with the idea that the distribution will be approximately normal. So we've met our 3 conditions. Okay, so here are the actual calculations, right? This is the in state, plan, do, conclude, which is Darren's 4-step process. This is the do portion. A confidence interval is made up of a statistic, p hat, plus or minus critical value, Z star, that's how many standard deviations do we have to go out to capture that level of confidence, and the standard error, square root of p hat times 1 minus p hat over n. These two things together, again, form the margin of error. Our starting point plus or minus this margin of error. For 99%, we will have to determine how many standard deviations do you go to capture 99%. Because remember, 68, 95, 99.7, 99 isn't one of those. So we will have to do something with this here, but that will be coming in just a second. These are the calculations. Again, I'm going to show you in just a second how to actually do this on your calculator. This is the work that will need to be shown if you're doing the AP exam. This is what they like to see. You can still do it on your calculator, but show your work. But we're going to do this on your calculator. Your calculator knows this formula. To figure out what Z star is, we got to do an inverse norm. The original problem said we want 99% confidence, so we want to capture 99% of the values. That means a total of 1% is together in these two tails, which means this is half of 1%. Okay, thanks for erasing it, Mr. G. Half of 1%, we do an inverse norm with 0.005, because that's half of 1%. And that will tell us what Z star should be. That it ended up being 2.576. You go out 2.576 standard deviations, you capture 99% of the values. So what this says is, remember that 0.0636 that we started with? Well, we're going to add to that, and we're going to subtract from that 2.576 of these standard deviations. Add 2.5 times this, and subtract 2.5 times this. And that gives us this confidence interval. Now, I'm going to hopefully pause his video and bring up my calculator and show you. Remember these numbers. 170 people said yes. 2,673 people were asked the question. So here's my calculator. Am I still recording? Yes, I am. Okay. Brilliant, brilliant transition there, Rex. Thank you very much. Right, here's my calculator. This is goofy on here. Here's the keypad. Here's the screen, right? But I think you'll figure it out. So we have to know some numbers, right? I jotted them down just because. So if we go on here, it's not in our distributions where we did like norm CDF and all binom PDF and CDF. We go to stat. Just click stat. Now, this is where we would put things in our list 1 and list 2. Scoot over here to calc. This is where we would do things that are in our list 1 and list 2. We're not in either of those. We're going to scoot over to tests. There's a whole bunch of things in here. Nothing that actually says test is what we're interested in right now. We are interested in an interval created from one proportion. So if you scoot down, you will find something called a 1 prop Z interval. One proportion using Z star to make the interval. 1 prop Z interval. And so when you click on that, it asks you for 3 numbers. X is the number of people that said yes. In our problem, there were 170 people that responded that they had multiple partners. N is the sample size. How many people did we ask this question? In this particular problem, it was 2,673. And then we have to tell it what confidence level. Now, the problem asked for 99% confidence. We're going to need to tell it, and you have to tell it as a decimal, 0.99. The calculator knows that 0.99 is 99%. You click calc, you enter, and there is the confidence interval. Notice 0.05144, 0.07576, with a p-hat of 0.0636 with this number, right? That's pretty much what our confidence interval was. I'm going to go back to Mr. G's screen here, I hope, and you'll see if I can go back to full screen. Come on, honey. There it is. There is that confidence interval, 0.0514, 0.075, it went out more decimals, but that's what that's the same confidence interval that we got, right? He adds one more thing in here. I'm going to show you what he asks his students to write in this little space right here. It's the 0.0636 plus or minus, and then he says, hey, what is this margin of error? 2.576 times this, apparently that equals 0.0122. The margin of error is 1.2%. So we're saying about 6% plus or minus 1%. Guess what? That gave us 5 to 7%, right? That is the confidence interval. That's the margin of error. The final part in Darren's state plan do conclude is, all right, what are we going to put in the Sentinel here? What's the point? How are we going to report this, right? This is great for us because we're stat wizards. The conclusion down here is going to be, what's our headline in the Sentinel? And we're going to write something like, I'm 99% confident that the proportion of all U.S. adults that have multiple partners is between these numbers. The conclusion is a sentence that makes sense to somebody who isn't a statistician, right? And so that's going to be the conclude portion of it. Another example, this is in your textbook on page 491. There's an example that's similar to this, and it goes through the same process. You can try it. Go to stat tests and do a one prop z interval and see if what you get on 491 is the same thing that you would get that they get on page 491. I might have just said the same thing twice there, but see that the answer that you get with the formula is the same as what you would get using your calculator, and that will be it. Most of today's homework, if you're following that plan, or the Tuesday, Wednesday part, is doing some calculations, asking for the state plan do conclude. State, what am I trying to do? Plan, check the conditions. Do, that's this, but really you're going to do it on your calculator. And then conclude, give me a sentence that tells what that means in the context of the population in your sample and whatever, what you're measuring. So that's it for today.